Hello guys, so welcome back to my YouTube channel. In this video I'm going to derive stream functions, which is this for uniform flow, then for sink or source, then I'm going to prove this for vortex. So I'm going to derive stream functions for these conditions. So let's write what is the formula, right? So let's say for the Cartesian, generally u is partial psi over partial y, right? So v is partial psi over partial x with minus, right? So this is the Cartesian. Then let's consider polar coordinates, right? So for the polar, ur is partial psi over partial theta with 1 over r, right? So this is u theta is minus partial psi over partial r. Okay, so these are the general formula, right? So let's go to the uniform flow. First one is uniform flow. So for the uniform flow, let's consider like this flow, which is have a angle with alpha to the horizontal line, right? So let's say this velocity is u. Then when I consider the polar coordinates, let's say this is capital U, right? So I can say u, right? So u is, this direction is x, this direction is y. So this component velocity is u, this component velocity is v, right? So u equals to u cos alpha, right? And v equals to u sin alpha, right? This is simple, right? So looking at this formula, I can write u is equals to partial psi over partial, which is y, right, equals to u cos alpha, right? So I can actually integrate this. So psi equals to u y cos alpha, right? Similarly, I can write u x sin alpha, so I get the same answer, right? Okay, so for the uniform flow, this is the potential, sorry, this is the stream function, right? So let's consider a source or sink, right? Let's say it is a source. So if it is a source, it creates flow, right, to the outside. If it is a sink, it takes the flow into the origin, right? So this is a sink, this is a source, right? It is the difference. So let's say this strength is n and this strength is n. This should be positive and this should be negative, right? This is the sign convention, right? So now I'm considering a source, right? Source. So what is the strength of the source, right? M is strength, right? So I can define the strength as flow rate over unit length, right? So flow rate over unit length. So if I consider this as 1, so this should be flow rate, right? Flow rate. So let's consider the flow rate, right? So now I'm considering polar coordinates, right? So this is my source, it creates flow outside. Okay, so let's consider a line like this. So this tries to move with the velocity u r, right? So what is the tangential velocity, which is u theta? It is 0, right? So this has a velocity u r, right? Let's consider it is as u r. So using the polar coordinates, I can write partial psi. I need to write u r, right? U r equals to partial psi over partial r, sorry, this is partial theta times 1 over, right? Which is written in here. Okay, so I know u r equals to u r times r is partial psi over partial theta, right? So let's consider the strength. M is flow rate times flow rate over 1, right? So this is simply area times sorry, this, let's say this is a, so area times velocity, right? Which is u r over L. So this area means let's consider like this. If this is the source, it creates the flow like this, right? So I am considering this is the L, right? Sorry, this is the L. So this is the perimeter, right? So area means this, right? So area is L times its perimeter, right? Which is 2 pi r. So I get, sorry, this is L times A, right? Sorry, this should be L times 2 pi r, right? So L to L cancels out. So 2 pi r u r equals to m, which is u r equals to m over 2 pi r, right? So I can substitute that in here. R times m over 2 pi r equals to partial psi over partial theta. So r to r cancels out. So this implies psi equals to m theta over 2 pi, right? So this is the stream function for source, right? So if this is a sink, m is replaced by negative m, right? So that is minus m theta over 2 pi, right? Okay, so let's consider a vortex, right? So the last one, which is vortex. So if this is a vortex, we need to think about the circulation, right? Which is otherwise vorticity. So let's consider a point like this, and let's say it has a vorticity like this. So generally I can define this as so let's consider it has r, right? This is my polar coordinates r, and which is I have a velocity for this as 0 and this as u theta, right? So here u r equals to 0, but it has a tangential velocity, right? So I can define this circulation as velocity times length of the direction, right? Which is 2 pi r, right? So because every time u theta is in this direction, so length is equals to perimeter, right? So I can say u r equals to, sorry, this is u theta, right? U theta equals to tau over 2 pi r, right? Okay, so now right, then I can write the definition u theta equals to partial psi over partial r with negative, right? So minus, sorry, tau over 2 phi r equals to minus tau phi over tau r, right? So by integrating this I can take phi as uh, uh, tau over 2 phi is a constant, so I need to integrate r dr, right? So this is simply uh, tau over 2 phi ln r, right? So there is a negative sign here, so there's a negative everywhere, right? So this is the stream function for a vortex, right? So I proved I proved stream function for the uniform flow, then for source and sink, and for a vortex, right? So if you guys have any questions, please comment below. Thank you for watching.